I'd like to talk to you today about Techfiles. What is a Techfile? A Techfile is a file in your library for keeping the relevant technology information. The file is binary, so you can't read it directly. Designs are kept in a library as data. The library has cells, each of which may have several views or data for different applications. The Techfile is usually inside the same library containing the data. It has technical information associated with the technology used in creating the design. Any object related to the technology can be referenced from the Techfile, though tech objects may also be set within the application. The OpenAccess API has classes for dealing with various technology file type objects. Constraints may be defined in Techfile. Attributes of the technology may be defined in the Techfile. The manufacturing process can be defined within the Techfile. All the designs in the library are normally referenced in the primary Techfile. The analysis lib is outside the OpenAccess database. The Techfile enables a reference to that library so you can get important information such as operating points or PVTs. The tech header is created dynamically and allows the application to check which Techfile is being used. If you attach another Techfile, it becomes primary. Layers are defined in the Techfile along with their purposes, their parameters too. The site def defines the distance between the placed instances. Placement tools depend on this. Vias, standard and custom vias, along with their variants and via arrays, can be defined within the Techfile. The Techfile may be in the library or it may not be. For example, our NAND gate 45 library is specific to the 45 nanometer technology, so it has a Techfile within the library. Our free analog symbol library contains schematic symbols that may be used in schematics for multiple technologies. It has a Techfile as a separate library. So suppose you want to switch Techfiles within your application. You can attach your library to a different Techfile or detach it. Only one Techfile can be attached at a time. However, you can use references from one Techfile to another. Okay, let's talk about attaching Techfiles. Okay, I've got a script here that will make us a set of libraries to use for our testing. And the libraries it made are toplib, reflib top, reflib A, and reflib B. And you'll see reflib A has a Techfile created, reflib B has a Techfile created, but toplib has no Techfile. So what I want to do is run a utility that will allow us to dump a Techfile. And let's look at toplib. I expect this to fail because there's no Techfile to look at. And it did. So it can't open that Techfile because it doesn't exist. So let's look at reflib A. Reflib A has a Techfile, and it contains 3 metal layers and a whole bunch of purposes, database and user units. That's pretty much it. So let's look at reflib B. Reflib B's Techfile contains implant layers. So where A contains metal layers, B contains implant layers. Same purposes, DBU per unit, user unit, and all your other definitions. I have a script here that will attach references And the first thing it's going to do is open reflib A and Techfile of reflib A. Then it's going to open reflib B and its corresponding Techfile. And at that point, it's going to try to attach reflib A and reflib B. But for now, let's just attach reflib A. And it also detaches at the end. We will try to just attach reflib A. We're going to attach it to the top lib. And it echoed back that it has attached the Techfile from reflib A to top lib. So now if we list, we see that top lib still does not have a Techfile. It does have a data file though. And what if we run our dumper on top lib, we see that it now thinks it has a Techfile containing meta layers, which is what we saw in Techfile, the Techfile for reflib A. So now let's go back to our script, and we will bring in an attach of reflib B shortly after reflib A. Now we have a Techfile attached from reflib B. So now if we take our dump utility and dump the top lib, you'll see that it now has the implant layers which were in reflib B's Techfile. Given that, now we will put a detach statement at the end and run it again. Running it the script again. And now let's see what it did. And it can't find a Techfile. And looking at our libraries, reflib A and reflib B still have their Techfiles. Top lib still does not have a Techfile, but it still has a data file. Yet it can't find the Techfile because we have detached the Techfile from the library. While only one Techfile at a time can be attached, the Techfile may contain many references to other Techfiles. If there's no conflicting information in the Techfiles, then multiple Techfiles can be referenced. There's a validate method to test for conflicts. Validate actually uses the Tech observer to determine if the reference has conflicts. If so, false is returned. The Tech header class has the methods to examine your references. It also handles the binding of the references. References are persistent in the library unless an application releases the binding. You can have references in an attached Techfile. You can reference one Techfile from another. You can reference multiple Techfiles from the top Techfile. Let's look at an example of referencing a Techfile. Okay, let's look at a example of using Techfile references. I've created a directory here and built some libraries in them. I have a utility called dumptech that shows you what's in a given library's Techfile. So Let's look at the libraries I've created. RefLib has a tech file in it, and RefLib-A's tech file contains meta layers, just strictly layers 11, 12, and 13, all of the purposes and the basic settings, and that's all. Now, if we look at RefLib-B, RefLib-B contains only diffusion layers. So the RefLib-B layers are exclusive to the RefLib-A layers. Here's a script called add tech reference, which shows you how to add references. First, you open your library, of course, and all of the libraries that you open, you also want to open their tech file. So RefLib-A and its tech file, RefLib-B and its tech file. And then this is the heart of the matter, is to add the tech reference. It's very simple. You take your tech pointer and add the tech reference to the tech file that's open. Here we create a reference array. This is the array for the tech headers, and we're just creating the array there. And so we create the reference array from the tech headers, which gives you the ability down here to go through those tech headers and find each of the individual tech files, and it will show you what's in them. And then I've appended them to an array to have all the tech files handy for convenience. This command is unset references. If you do that, you will lose all your references, and I want to show you this in example form. So let's keep those. And this tech validate will tell you if there was any conflicts. If there were no conflicts, it's going to give you validation passed. Otherwise, it's going to tell you that it found conflicts. And then we save tech file, and the references should be set at that point, and from then on they'll be persistent. So if we run that, and I will run that pointing to reftop is a library that we're going to reference RefLib-A and RefLib-B from. And it found there were two elements in the tech headers. RefLib-A, it was bound, and RefLib-B, it is now bound. Validation passed, so there were no conflicts. So now if we run our dumper on reftop, we see all of the layers from both Techfile, the RefLib-A and RefLib-B combined. So the reference created yet another tech file with the common set of items that were in both of those. And in reftop, you will see the techdb file. RefLib-A and B referenced in reftop tech file. We look at a dump of reftop. Again, we see all the complete set of layers. Okay. Now, use a conflicting library. I created another library called RefLib-A conflict. Let's take a look at that library's tech file. It has metal 1, 2, and 3, but it has poly on layer 8. And if you'll recall, Techfile B had poly on layer 9. So that should create a conflict. So if we go into our add tech and we change RefLib-A to RefLib-A conflict, And now if we run our add tech reference script on RefTop, now we have found objects with conflicting parameter values. And we know what the conflict is because we introduced it. But the validate function, it runs. It's what it's doing is watching the observer and getting back a binary answer from the observer to tell you if there were conflicts or there were not. Now, to go further, you would need to go into the observer and get out the text from the tech observer specifically, and then you have all sorts of ways to take actions based on that to resolve conflicts, but that's an exercise left to another demo. And with that, you should have everything you need to use references. The application may create a top-level tech file if none exists in your library. The reference binding will be created if there are no conflicts. When the application attempts to set the reference, conflicts are identified at that time. The validate method checks the observer to see if conflicts exist and returns true if there are none. The reference tech file cannot be bound if conflicts exist. To get specific information about the conflicts, the application must use the observer, specifically the Techfile observer. The observer template is used for many other things besides the Techfiles. Though it has implementations specific to Techfiles, the Techfile conflict types are enumerated so you can test for each case. Thank you.